Hello guys, this is Yogesh and welcome back to Tesla Talk. So today in this video, we will learn about the control schematic of a medium voltage circuit breaker. We will simply break it down and we will talk about the closing and tripping circuits. Then we will talk about its key components like switches, fuses and coils. Okay, so let's start. So here is the control schematic we are working with, and it is divided into two main sections. Okay, and they are labeled as the closing circuit, and there are two tripping circuits, and they are labeled as trip circuit 1 and trip circuit 2. So you can see here. Okay, and each circuit has key components that allow us to operate the breaker safely and reliably. Okay, so we will talk about the closing circuit now. So you can see this is the closing circuit. Okay, which is starting from here, from this fuse FC1, then it is ending here, the FC2 fuse. So let's start with the function of the closing circuit. Okay, so why the closing circuit is important, which is we can say that the closing circuit is responsible for closing the breaker and allowing the current to flow. Okay, and the closing circuit begins with the FC1 and FC2 fuses. You can see here, and the fuses, they protect the circuit from overload. Then next we have the castle lock, which is here. You can see that here. So this is a castle lock, and why do we use it? The function of castle lock is to interlock. Okay, this interlock prevents the unauthorized or accidental operation of the breaker, and it must be disengaged before the closing command can be given. Okay, and the VCB 52 coil. So this one is the closing coil, and it is crucial here because it gets energized to physically close the breaker. That is why this closing coil is important to close the breaker. Now we talk about the switches. So you can see here, this one is the LR switch. LR means the local remote switch, and it allows us to choose between the local control of the breaker, and locally I mean on site. Okay, so we can locally control the breaker on site, and the remote operation from a control room. So the remote operation is used for if we have to control the breaker from a control room. Okay, then there is a TNC switch. You can see here the TNC means this stands for the trip neutral close, and it is a 3-position switch that allows us to send either a trip command or a close command to the breaker depending on the situation. When in the neutral position, it means there is no command is sent. Then there is an anti-pumping circuit. So it is starting from here, the 94. This is the code for the anti-pumping circuit, ANSI code. Okay, so 94 is the code for anti-pumping circuit, and the 94 here it is shown also. Okay, so this is the NC contact of the breaker. NONC, it is a changeover contact. And the function of anti-pumping is it ensures that the breaker doesn't repeatedly attempt a close if a close command is given multiple times accidentally. Okay, and this protects the breaker from being damaged due to multiple close operations. And then here is the trip circuit 1 and trip circuit 2. So this one is the trip circuit 1 and this is the trip circuit 2. Now we will discuss the trip circuit, which open the breaker either manually or automatically during faults. Now we have two tripping circuits here, and this provide a redundancy to ensure the breaker trips reliably. So that is why we are using two trip coils here. Okay, If one trip coil fails, then the second coil is comes into picture. Then we will see how the trip circuit 1 works. So it begins with the FT1 fuse. Okay, so this one is the beginning fuse. Okay, FT1, which is a 6 ampere fuse. Then this fuse protects the trip circuit from the overcurrent, then which is similar to the closing circuit. And just like that, there is a LR switch 2, and there is a TNC switch. Okay, so I have already told you the function of the LR switch and the TNC switch. You can the local remote switch will allow us to operate the tripping either locally or remotely. Then there is the TNC switch in the tripping circuit. It works in the same way as in the closing circuit. It can be used to trip the breaker. Okay, set it to a neutral. There is when the TNC switch is in neutral position, then there is no command. Or to close the breaker, we can use that TNC switch. Okay. Then we will see how a trip signal is sent. Okay, so when a trip signal is sent by this fuse, okay, then it energizes the VCP52 tripping coil. So you can see here, this is the trip circuit 1 and this is the trip coil 1. Okay, VCP52 is the trip coil, and this trip coil energizes and it opens the breaker, which is cutting off the which will ultimately cutting off the flow of the electricity and protecting the system during fault conditions. Okay, and just like that, there is also the trip circuit 2, which is the function of trip circuit 2 is same, and there is the same wiring logic used in the trip circuit 2 function, just like in the trip circuit 1. Okay, so the main purpose of trip circuit 2 is here that it will ensure that if the trip circuit 1 fails, then the other can still perform the tripping operation. Okay, so this is how the trip circuit works. Now we will see the key components. Okay, the FC1 and FC2, these are the closing circuit fuses which will protect the circuit against the overcurrent. Then FT1 and FT2, these are the tripping fuses. Okay, they will perform a similar protective function. And then VCP52, we have seen that those are the coils, closing and tripping coil. Okay, and they will responsible for both closing and tripping the breaker depending on the command. Okay, then there is a castle lock which will prevent the unauthorized operation of the breaker. Okay, then there is anti-pumping circuit which will stop the breaker from attempting multiple close operation due to faulty or repeated commands. Then there are LR switch and TNC switches. So the local remote switch allows the operation control from either on-site or a remote location. Then there is a TNC switch, which is a trip neutral close switch, which sends either a trip or close command depending on its position, which will the neutral is the default position of the TNC switch. Just keep that in mind. Then there are some protective relays also. There are some relays used which automatically trips the breaker during fault conditions, ensuring the system safety. Okay, so take some final notes. Okay, so this is our entire schematic drawing. So we will wrap this up now. Okay, so this schematic gives us a clear picture of how a medium voltage circuit breaker is controlled, and the closing circuit ensures that we can safely close the breaker. Then while tripping the circuits, provide safety mechanisms to open the breaker during fault or maintenance. Okay, so this is the control schematic. Okay, so this one is the short video to explain the control schematic of the medium voltage circuit breaker. Hope you like this video, and if you want me to make more videos like this, then just do comment and I'll make a video on it. I'll definitely make it. Okay, so thank you for watching Tesla Talk, and we will see you in the next video.